Significant figures are very important in chemistry. A significant figure is a number that is measured. And when you are measuring, you always want to estimate one additional digit past um, the numbers that you know for sure that you've measured from the instrument. What I mean by this, let's look first at this bottom ruler. So this piece of copper metal here, when I look at how long it is, I see that for sure it is 8 centimeters. But it's a little bit more than 8 centimeters. It's just not marked past the 8. So 8 is what I can measure for sure, and then I'm going to estimate one more digit. And so looking at that length, I see that it's in between the 8 and the 9. It's a little bit more than halfway, so I'm going to say it's 8.6. So I was able to measure both these numbers. So I know the 8 for sure, and then I estimated one more digit. That's the 6. And then whenever you measure, you always want to include the unit. So I look at the unit that the ruler is measured in. It's centimeters, so I am going to put the unit cm for centimeters. Let's look at the top ruler. So against the same piece of copper, and I for sure again can measure to the 8. And then you see that there's some additional markings here. So I can see that I can measure to the point 1, 2, 3, 4, 5, 6. So looking at that bottom ruler, we did a pretty good job, because the top ruler agrees with what we guesstimated that it is. Now notice this one also, you have the opportunity to estimate here. So I see that it's right in between the 6 and the 7, and so that's just a judgment call. I think it's about in the middle, so I'm going to call it a 5. So this is 8.65 centimeters. Now look over here to the burette. This burettes are a little bit different in that they measure how much liquid has come out of them. And so you see that it started at the 0 and it dispensed at least 20 millimeters. And looking at this more detailed, we see that we can even measure to 22 millimeters, or excuse me, milliliters. And then we again have the opportunity to estimate. And they're estimating that it's 22.2 milliliters. And maybe you think it's 22.1 milliliters, and that's fine. Again, that last number is estimated. Now, after you do this measuring, everything that you've measured, those are your significant figures. So right over here, this one had 2 significant figures, or 2 numbers that we measured. Over here it has 3. In our burette it has 3. So again, it has numbers that we measured, and then the last number we estimate, and we only estimate one digit. So let's go through the significant figure rules. These are on the back of that goldenrod reference paper that I gave you at the beginning of the year, and there's 5 of them that we're going to go through. So the first rule is when you look at a number, anything that's not a 0, you for sure have measured that. So that is, they're all measured numbers if they are not a 0, or they're all sig figs. So that first number, we have 3 sig figs. And by the way, sig figs is just a little shortened way to say significant figures, and it's kind of fun to say anyway. Look at the middle number. So that middle number has 4 sig figs, and the last one has 5 sig figs. So those are all measured. The second rule, all zeros in between non-zero numbers are always significant. So the logic here is we have numbers that are not zeros at the beginning and at the end, and the zeros are sandwiched in between, and they are all measured. So that's first one. This is 4 sig figs. And the second one, this is 3. And the last one, kind of a double sandwich there, has 5 sig figs. Or in other words, 5 numbers that have been measured. All right, rule number 3, leading zeros are never significant. So leading zeros are placeholders. So for example, this first number, I have 0.05 grams. So what is this representing? I might say, oh, I have 5/100th of a gram in that beaker. So it's a really, really small amount. It's just an estimate because I only have 1 sig fig. And then the next one has 2 sig figs. So I'm able to measure that 2 and a 5 to a really, really small degree there. All right, Trailing zeros are significant only if the decimal point is specified. And there's a hint, change the number to scientific notation. So that is discussed in another video. Uh, this rule, the trailing zeros and the previous rule, the leading zeros, they can be confusing for students because some zeros are measured and some are not. So trailing zeros are not measured. So there again are just placeholders. So for example, look at that first number. So 200 grams. How heavy is that beaker? Oh, 200 grams. So it's just an estimate. I really only have one sig fig in this answer. Now, however, if I were to put a decimal behind that 200, all of a sudden I have 3 sig figs. And that's because that decimal means that I did measure to the ones place. So that I did measure that last zero. And so that decimal locks it in that it is a digit that we did measure. So this is a little bit confusing. So I always use this rule, dot right, not left. The dot is a decimal. So if you have a decimal, start counting from the right. If you do not have a decimal, start counting from the left. And this helps you to figure out whether you count the zeros or not, because that's kind of confusing whether you count them or not. So for example, let's use dot right, not left on the first number there, so 200. So there's no dot, there's no decimal, so I'm going to start counting from the left. So I'll just count until I run into zeros, and I just count 1 sig fig. Let's look at the next one. I do have a decimal, so I'm going to start counting from the right, and I will stop counting if I run into any zeros that are at the end of when I count. And you can see that I don't run into any zeros at the end. So I just start counting and I end at the 2. That's 3 sig figs. Let's go to the next number. How many sig figs is here? There is a decimal, so start counting from the right. And there's no zeros at the beginning, so I have 4 sig figs. And let's look at the last example here. I do have a decimal, so I'm going to start counting from the right. And I'm going to stop at that 4. These right here are not counted. This one has 4 sig figs. All right, so I have a 0 at the end of this one, so 0.040060. And the way I look at it is they must have measured it if they tacked on a 0 at the end. Otherwise, they would have just ended at the 6. So maybe logically you can think of it that way, or always fall back on the dot right, not left. All right, one more rule, and it is the counting number rule. When you have numbers that you're counting, and usually your units will be something, they could be something that doesn't sound like science. So for example, this first one says 5 people. So you just count 1, 2, 3, 4, 5 people. You don't estimate a portion of a person. That would be gross. So this is a counting number because there's no estimation. You just count what you have. And as a result, it has infinite sig figs. So 5 people would be the same thing as if I had 5.000000 infinity people. That's all the same, okay? The second example here, I have 22 books. Again, counting numbers, it's all infinite. And 9 apples. So apples doesn't sound very sciencey, but this is a counting number. So infinite number of sig figs. Where this rule is important is your conversion factors. So even though your conversion factor is written like this, 12 inches equals 1 foot, it's not 2 sig figs and 1 sig fig. Because this is a conversion factor, it has infinite sig figs. So I could write 12.0000 equals inches equals 1.00000 feet. As many significant figures I need. So this is important that when you are converting units, when you're doing factor label or dimensional analysis, and you look at the number that you're starting with, you want to preserve the number of sig figs that you have. And so you're not going to round this to 1, for example, because this is not 1 sig fig, this is infinite. So your conversion factors aren't going to help you determine how many sig figs you have. You would go from the original number, how many sig figs you have in your answer. All right, let's do some practice here. So go ahead and stop the video and see if you can complete this. All right, we're back. Let's go ahead and figure out how many sig figs are in each one of these. So in this first one, so there's a decimal there, so I'm going to start counting from the right. So counting over, I have six sig figs. And let's look at, oh, I'm sorry, I counted wrong. 5 sig figs. 1, 2, 3, 4, 5. Let's look at number 2. Number 2 has 1 sig fig. Again, no decimal, so I'm going to start counting from the left. And I just count the 3 and then I stop. So those are all placeholder zeros. Number 3, this one has 3 sig figs. Number 4, don't be confused. It's not 1 sig fig, it's infinite. And last but not least, this one has 4 sig figs. All right, so what about when we add and subtract and multiply and divide? We want to maintain the same degree of accuracy of what the numbers that we measured and have that represented in the final answer. So this first rule, the addition subtraction, we don't use it as much as the multiplication and division rule, but it's still important to learn. And for this one, I really call this the how many places past the decimal rule. So for example, in this first measurement that was made, we were able to measure to the tenths place or 1 place past the decimal. Okay, and then the second one, I have 3 places past the decimal. And so I was able to measure to the thousandths place. So when we look at my answer, even though my calculator says this, we have to round to the proper number of sig figs. And the proper number of sig figs is the least degree of accuracy, which would be the tenth of a gram that I was able to measure in the first one, or the 1 place past the decimal. So I cut my number off right here, and my final answer would be 150.5 grams. Let's go ahead and have you practice with these 2 examples here. So go ahead and stop the video and then we'll come back and go over the answers. Okay, we're back. So the first answer, you can see that the second measured number here, we're able to measure to the hundredths place, so 2 places. The other one has 3, and so we want to cut our answer off with just 2 places past the decimal. And with the second one, notice right here we only have 1 place past the decimal, and so we're going to cut off our answer to match, so 1 place past the decimal. All right, let's look at the multiplication division rule. So this is the one that we use the most in chemistry. Maybe 90% of the time we use the multiplication division rule. And for this one, you need to know how to count how many sig figs there are in a number. And so that's why we went over those 5 rules over and over and over, so that you would be able to count how many sig figs there are. So looking at these 3 numbers that we're multiplying, so this first one has 2 sig figs, the second one has 3 sig figs, and the third one has 4 sig figs. And my calculator says this. Where do I round off? Well, I'm going to go with the least degree of accuracy, which is 2 sig figs. So I just count how many sig figs we have. So I count 8, I count the 7, that's 2 sig figs. I'm going to cut it off. Now notice when I cut it off, if there is a number that's bigger than 5 that's going to get cut off, so either 5 or greater, you would round up. So the final answer of this is going to be 88 cubic meters. Okay, so again, because this only has 2 sig figs, then my answer is going to have 2 sig figs. So let's have you try with this example. So what is the correct answer with the correct number of sig figs? Go ahead and stop the video and then try to figure it out and then come back. Okay, we're back. So let's look at the first number. The first number has 2 sig figs. The second one has 2, and the last one has 4. So again, go with the least degree of accuracy, which is the 2 sig figs. So I'm going to cut my answer off right here, and my final answer will be 0.55 cubic meters. And that 0 that's at the beginning, that's just a little placeholder. So, so this only has 2 sig figs. Now, note about rounding. You always want to round at the very, very end of your calculation. So for example, if you did a preliminary number, you would want to not round until you get to the very, very end. So for example, if I needed to take this 0.55 cubic meters and maybe put it into a density formula, I wouldn't want to round it to the 2 right here. I would probably want to carry a few extra sig figs into that calculation. So, and how I would do that is you could write the numbers smaller. So that's a 1. I'm going to round it up to a 2 there. And so when I put that into my formula or my next calculation, that those the smaller uh, numbers would let me would remind me that there's only two sig figs there. Okay, so that's just a way to avoid rounding errors. So anytime you can just put the numbers in your calculator without writing them down before you get to your final answer, you're going to have more accuracy and less rounding errors.